Hey folks, sometime in January 2025, AutoGen released an update to its API, version 0.4. And version 0.4 is a significant rewrite of the entire framework with a bunch of interesting new features. So, for example, there's an emphasis on the entire stack being asynchronous and message driven. And we'll see what that actually means in a little while. There's an emphasis on modularity and extensibility. There's a nice, strong observability and debugging story. The new framework supports scalable distributed agents, and so you could have agents running on multiple different machines. And then there are built-in community extensions, there's cross-language support, and the entire library framework is strongly typed just to help you have less errors. And so in this video, I'll be covering several things, mostly just the basics. I'll be looking through installation. We'll walk through a hello world example, first using the AutoGen AgentChat high-level API, and then the low-level core API, and I'll sort of describe what these two things are. And it'll be mostly just a simple overview, and I think I anticipate we'll have like additional videos in the future to walk through more concrete examples. Okay, so here I have switched to my IDE, my VS Code IDE, and here we'll walk through a very simple hello world example that just shows us how to implement a simple setup where we have like one agent with a calculator tool, and it can respond to messages. As usual, we want to sort of pip install a package, and note that like here's what the package name is. The correct package name is, it's not AutoGen, it's not AutoGen, it's AutoGen AgentChat, and also AutoGen-ext. Next, we will import asyncio, which I mentioned earlier that the entire stack is async. So essentially, we will need like asyncio to run each of these like workflows as async programs. Next, we from AutoGen.agentChat.agent, we import assistant agent. Then from conditions, we import something called max termination, text termination. Then we import from teams, we import a round robin group chat from AutoGen.ui. This is mostly just login and console, just stuff to help us print the agent's like actions to console. And then we'll also from AutoGen extensions, OpenAI will import an OpenAI chat completion client. So the first thing we want to do is like we want to, let's say in this case, define a calculator function, and this is external to our multi-agent system. And then next, here's where all of the interesting or important magic occurs. So here we define a model client in a single line of code. So here we just say we're going to use GPT-4o using the OpenAI chat completion client. And so you'll notice here that I do not have an API key, but if you had one and you wanted to pass that in, this is where you would do that. In my case, I have API key defined as an environment variable. And this is probably something you want to sort of look at, just one way to set your API key. Next, we set a termination condition. So for example, how do we know when how do we define or control behavior as to when the task ends? So here we're going to define something called max message termination. And we set max message is equal to 10, or text message termination terminate. So what this means is that our expectation is that when we run this entire workflow or this agent, we expect that like the entire workflow ends either when we have exchanged the maximum of 10 messages, or any of the agents responds with text that contains the word terminate. Next, we define a basic assistant agent, and so here we just have a name for that agent. We can pass in a model client, which is a model client we defined above, and here we can define a set of tools. If we had more tools, we'll add them here, and if we had like a memory bank, we will definitely also add that here. And then finally, we have the concept of teams, and so AgentChat, the high-level API that AutoGen ships with, has a set of team presets. So you can think of a team as a container that takes a set of agents and essentially defines the order of execution and also the task termination conditions for those set of agents. And so here we have just a single agent. We can define another agent and put that into that list of participants. And so what the round robin group chat agent does is that it just schedules the agents, the list of participants that are sort of provided in a round robin fashion until a termination condition is met here. So if we run this, here's what we see. Here, it streams out like, here's the request from the user. What is the result of this number here? The assistant agent shows here that we actually use the function calling capabilities of the OpenAI model underneath. It says here, we are going to call a function. We're going to pass in this parameter for A and B and an operator, and the name of the function is called calculator. And that function runs. We see the result here that gets printed by the assistant agent. And then the assistant agent sort of responds with the result of this times this is approximately this. Okay. So there are a few interesting things here. We see here that the assistant agent says terminate. The reason why it says this is because by default, if you looked into the code, default code for the assistant agent, let's see if we can take a look here. And if we look at the default system message, it says you're a helpful assistant, solve tasks using your tools, reply with terminate when the task is completed, right? So in other cases, you might want your agent to respond with something else to indicate that the task is done. And once you make that modification, you can come here and sort of put that in. And so we see that the task is done. And the reason why the task is done is actually because this agent sort of responded with terminate. So far we have run a single team with a single assistant agent, but what if we wanted to run an additional a team with more agents? And so here we'll just extend this basic example to explore create a critic pattern. And so here we will have a base assistant agent that addresses a task, and we'll have a critic agent that is meant to provide feedback. And the expectation here is that as the critic agent provides feedback, the entire system sort of is structured such that the assistant can take advantage of this feedback, sort of explore more iterations on the problem until the task is done. So let's go ahead and try to express that with AutoGen AgentChat. And so it's a critic agent. Again, we'll model this as an assistant agent called the critic. We'll give it the model clients, but in this case, we do not need a tool. Now, to structure its behavior, we will probably sort of write up a system message, and we might say something like criticize the assistant answer and suggest improvements. Your critique, if there are, so we might say something like, if there are issues to be addressed, respond with the list of issues. However, if all issues have been addressed, respond with terminate. So this way, what we expect is that every time the critic agent responds, it will either give a list of feedback, or it will respond with terminate. And one other thing we might do here is we might come over and sort of modify the system message for the assistant agents here. The default message just include logic to terminate. We don't want the assistant agent terminating the conversation. So here we might just simplify this to you are a helpful assistant. Okay. And once we have this, so we can expand the team to add the critic agent. In here we probably do not need a calculator tool because we're going to have a fairly simple task, and it's going to be write a 5-line haiku. Okay, and we can save that, so you make it about ocean. Okay, that works well too. And so let's run that and see what the results look like. So here we have the assistant is reading this 5-line haiku, and then the critic comes up and says, hey, there are issues to address. A haiku traditionally follows a 5-7-5 pattern, and it suggests a bunch of things. Here's an example revision. And then the assistant says, thank you for the thoughtful critique. And then it makes some updates, makes an actual 3-line haiku. And then the critic is satisfied and it responds with terminate. And so, If you had to do all of these without a framework, it definitely can get into hundreds of lines of code. But hopefully the AgentChat API sort of shows what this could look like on a high level. So now we've done all of that, let's sort of take a look at how we might do this with the AutoGen Core API. Okay, so before we dive into the AutoGen Core API, an interesting thing, I think a question on the minds of many of the listeners is, when do I use the Core API versus the AgentChat high-level API? I think a good way to think about it is to sort of think through, like, what does each of these abstractions sort of support? Let's see, I think in this blog post I sort of have like some guidance here. If you're exploring an autonomous multi-agent systems where agents sort of chat or converse to solve tasks, I think most of the abstractions in agent chat, so things like the round-robin group chat, there are other team presets like a selector group chat, will get you there extremely fast. And so, for example, you could build something that's really close to the OpenAI operator or deep research agent in about 40 to 50 lines of code using the AgentChat high-level API. However, if you have custom business logic where data needs to flow or control needs to flow in a very specific predefined structure with constraints along the way, you are probably better off expressing this pipeline using the event-driven infrastructure in the AutoGen Core API. So this is something to keep in mind. I think many business applications with very, very well-defined constraints will probably benefit some more from the AutoGen Core API, or a mixture of both. Okay, so let's get back to what the Core API looks like. Okay, so how do we define a setup very similar to what we had in AgentChat, where we had a single agent that had access to, that could call tools, or a setup where we had like a single agent that could use an LLM and also could use tools? How do we express that in the Core API? So one thing you notice off the bat is it's just a lot more code. So compared to, let's say, 40 lines of code in AgentChat, we have about 150 lines of code. Let's just sort of walk through what all of that looks like. So first we have like the basic calculator, the exact same thing. Let's get that out of the way. Next we have an assistant agent. Let's skip that for now and come into sort of the main scaffolding for when we run, when we sort of run this application. So the most important new concept here is the idea of a runtime, and it's mostly focused on sort of instantiating agents, or manages the lifecycle of agents and manages the delivery of messages to agents. The other things here are sort of like framework level details. For example, we have the calculator tool wrapped in something called a function tool. We define a list of tools. Then we define a model client very similar to what we had in AgentChat. And then there's a concept of a tool agent, which is essentially just a high-level wrapper class that makes it just a little bit easier to sort of perform function calls. Again, this is a library or framework specific thing. And then finally, we have an assistant agent. And the key point is that both of these agents are sort of registered with the runtime. And the key idea here is that for each of these agents, we need to pass in a template of how a runtime object for this agent can be instantiated. And so here we have tool agent, a description, and a list of tools that it takes. Here for assistant agent, we register it with the runtime. And we also pass in a template for how this thing should be instantiated. So here it takes a model client, tool schema, and all of that. And then the next thing to do is to start the runtime, and then we send the message to the assistant agent. So once we hit send, what happens here is that as at this point, none of the agents that have been registered exist. Once we hit send message, what happens is that we create a message. So this message type is sort of defined earlier in the file. It's just something with content. And the next question is, how does the runtime know to deliver this message that's being sent to the assistant agent? And so let's take a look at the implementation here. So the first thing to notice is that the assistant agent is based on something called a routed agent. So it's a base class for agents that route messages to handlers based on the type of the message, right? And so here, if we look at this method here, there's a method called handle message. It has a special decorator called message handler. And in its argument, it has like a message argument of type message. So what that just tells the runtime is at any time, if there is a message of type message, that message should be delivered to the queue for this specific agent. And then we should call this method called message handle message, because it has this decorator, and sort of implement or the logic that sort of is in there. And the logic in here is sort of relatively simple, mirrors most of the behavior from AgentChat, just with a lot more code. So set up a model client, set up some scaffolding to enable us call tools. We need a way to keep track of the number of messages we've sort of processed so far. And then in the handle message method, we have some logic around termination. So if it is terminating the content, or if we've exceeded a maximum number of messages. And then we also have like some logic to sort of call to call an LLM in a loop. So pass in a model client, a list of messages, and essentially just some helper function to let us like call an LLM in a loop. As you mean, we also have like tool calls in loop. We have tool calls generated by the model, just get executed until no more tool calls are sort of generated. And then once that is done, we can send out a message response, and that essentially is sort of cut here, and then that is printed. And then at some point when no more messages are sent, nothing else is put on the messaging queue of the runtime, the entire application is completed. So let's take a look, let's run it. And while all of this is, while things are getting set up, so in this case, it says the result of this multiplication is approximately this. Sounds about correct. One thing I should mention here is, I think I've only touched the surface of what the core API can do. And so in this case, I talked about how messages can be routed based on the type of message that is sent. However, in practice, the core API also supports subscription-based message delivery. So you can explicitly define agents to listen on a channel, and whenever messages are sort of published or sent to that channel, so in this case, send message or publish message is something that either an agent can do or the runtime can do. And as long as an agent is sort of registered to listen on that topic or that channel, then the message gets routed to that agent and that gets executed. And it turns out that if you sort of structure your application through this sort of, some entities that are registered to receive specific messages while others aren't, you can sort of compose that into very complex workflows that fit your business logic. And I'll probably make some more videos in the future to show some more examples of what that could look like. Okay, so all of the things I talked about today, I do have a blog post that's sort of titled The Friendly Introduction to the AutoGen Framework, version 0.4. Take a look. It covers exactly what I've talked about in this video today. Covers both of the APIs, core and AgentChat, walks through some examples with some additional sort of explanations of how things really work under the hood. In addition to that, I think the other interesting thing to note here is that the AutoGen v0.4 ecosystem is pretty rich. And so on the framework level, we have like extensions, we have the AgentChat high-level API, we have the core API. And for both AgentChat and core, they share a lot of components. So for example, models, OpenAI, Azure OpenAI, Azure AI Foundry, tools, and then memory abstractions are all shared across both of these APIs in the framework level. In addition to that, there's AutoGen Studio. I have made a video on that previously. Take a look. And then there are apps like Magentic One and probably whatever app you're gonna develop. And finally, I think code for all of this, you can find that on the labs on the multiagentbook.com website. If you go to labs, I think it's the Hello World agent. And the interesting thing is that you could sort of take a look at, compare what the exact same code looks like in AgentChat versus core. So again, if you recall, we sort of saw that for AgentChat, it was about 40 lines of code. For core, you get a lot of low-level control. So for example, how messages are routed, what type of messages should a specific agent respond to, and all of that. but you just have to write a lot more code. And just also for comparison, I do also have like an implementation in LangGraph, so how you would implement something similar in LangGraph. So take a look. Right now, I think there are about 8 example implementations. So for example, RAG agents, the router pattern, how to generate a book using a custom model client, in this case using Gemini 2.0, deep research agents, web agents. Take a look and let me know if you have questions. And I'll see you guys in the next one.